Hi everyone, my name is Elisa Torres Gournay and I'm the founder of Girls in Quantum. Today I'm super excited because we're launching our first series of interviews with people in quantum, and in this first chapter we had the honor to interview Juha Riippi, CEO and co-founder of Quan. So thank you Juha for being here today, and I'll let you introduce yourself.
Okay, well, first of all, thanks for having me. And yes, hi, my name is Juha. I'm the CEO and co-founder of Quan. My background actually isn't too much in physics or mathematics or quantum, as many people do. I come more from traditional software development side and business side of things. So what I bring to Quan is, well, I'll talk more about it later, probably in the questions, but we're kind of building a physics simulation suite, which includes also classical computing, cloud computing, and actually it's going to be a B2B SaaS product. So I have a lot of experience working with SaaS products and kind of building those and on the business models and on the sales side of things. So if you want to know something in details about how our quantum algorithms work, I'm not the right person to answer those questions, but I can answer the use cases and the applications for sure.
Great. So why did you decide to follow the path of quantum computing specifically? I was wondering.
Well, that was, for me, it was sort of a coincidence. So when we founded, or before we founded Quan, I met the other co-founders through a common friend who introduced us, basically introduced us with the agenda that these people are thinking about starting a business around quantum computing, and they would like somebody who's kind of has a more commercial background to join the team. And yeah, well, that was in spring 2021. Quan is quite a young company. And out of that coincidence, of course, I started intensively looking into what can be done with quantum computing and what are use cases and what the benefits are and all that. And well, I got really excited on what could be achieved with this awesome new technology. And yeah, from there, that's now 1.5 years ago. So it's been a wild ride.
Great. Well, that sounds awesome. And I was also looking at your website, and I was wondering why physics or quantum simulations. So could you explain to me a little bit more?
Sure. So yeah, basically what we do is kind of these multi-physics simulations. So what our current product that was released in October, it doesn't contain any quantum code in it yet because of kind of the early stage of the technology, but our algorithms can simulate like computational electromagnetics, computational fluid dynamics, and solid mechanics simulations, or any combination of those. And really kind of sweet spot use cases can be things like simulating MEMS devices, piezoelectric devices, superconductors, electric motors, or these really advanced 3D magnetic simulations. And already with the cloud technology, we can sort of speed it up significantly. But then in the meanwhile, we're also researching quantum algorithms that actually do pretty much the same thing, but just on a way bigger scale and way faster. So one thing I often use as an example is, for example, if you think about airplanes and how to do the aerodynamics testing for them, typically what you do is you build a model or you build the actual airplane and you take it into a wind tunnel and really test it. Then if you have to change something, you need to go back to the drawing board and you actually need to build another prototype for testing. And with quantum computing, this could actually be replaced with simulations. So the simulations are based in quite complex turbulence models and Navier-Stokes equations, and we know how to solve them, but there's just not enough computational capacity. It would be tens of years to compute them, so it's completely impractical. With quantum, that's potentially minutes. And if you think about what that would do for an airplane design process, because if you have to make changes, you just go and reiterate your digital model or your CAD drawing and then run another simulation. So it could take even years out of an airplane product development phase. And there are lots of similar examples for other industries too.
Yeah, of course. And thank you for mentioning like a real life example, since sometimes many of us imagine like, wow, that's really cool, but it's not always pictured as in one of our daily life activities. So that's definitely good to know. And well, I was also wondering, since there are many definitions from people and experts, from you or for you, what is quantum computing?
What is quantum computing?
Yeah.
Well, for me, like personally, it's something I honestly don't fully understand, because like, I mean, quantum computing, it's a completely new paradigm for computing based on the principles of quantum mechanics. And I don't know if anybody really understands quantum mechanics. I think, I don't remember who said that, but somebody, at least in the quantum, said that whoever claims to understand it is lying. Well, I definitely don't understand it. And that's one of the things I've been kind of struggling a lot with, is that you cannot explain it without very advanced mathematics and kind of the language of mathematics. And I'm not like the most capable person in mathematics. So when I started looking into quantum, I had to go back to the university math classes I did 17 years ago or something, and kind of revisit all that stuff. It wasn't enough, but it kind of, at least I got the basics. But yeah, anyway, I think I got lost a bit on the topic, but yeah, a new computing paradigm based on like completely new phenomena, making it possible to solve way more complex problems.
Great, thank you. That's definitely a good definition. And I was also, since you mentioned, well, that it was like kind of a struggle or like an issue not understanding, like because nobody understands really like quantum computing. That's I totally agree, and I've heard that from many other people as well. So for you, what has been like some challenges, like personally in the field of quantum computing?
Well, it's definitely related to kind of the because in my previous career, I was typically, I did a lot of sales, I did a lot of business related things, but I always understood the technology quite like deeply. Then here it's just I couldn't do anything with a quantum computer. I've done some like IBM quantum experience, like beginner classes or stuff, but I'm miles away from getting anything useful done. So it's been sort of a learning curve for me to really just rely on kind of other people's expertise without understanding on what the problems even could be, and sort of well, yeah, a whole new approach to sort of working with technology that I don't understand. I guess that's been the by far the biggest challenge. And well, in addition, of course, to that, there's a lot to learn on all the potential use cases for quantum computers, but those I can understand. So it's just about learning them.
Okay, great. And well, also like I have to mention about the challenges for quant science. I believe that well, any companies have these challenges throughout their period of time. So I was wondering, what has been like the challenges for quant science so far?
Well, it's probably one of the big ones has been, since we were founded in late 2021, and sort of the world economics took a downward twist quite early in 2022, and we're not, of course, alone in this, but I mean, raising funding for startups is way more challenging than it was 1 year or 1.5 years ago. So that's definitely been one and of course also like one of the things. So as a quantum company, we're sort of different to many others, since we also have this like B2B SaaS thing and the cloud computing thing. So that can be seen as a big positive because we have this near-term revenue potential. but then again, it's also a challenge. It's also almost like building two companies at once. So there's always the quantum, and we want to connect them at some point, but right now the technology just isn't there. We can't bring our quantum algorithms into our simulation platform. It wouldn't make any sense at this point.
Of course. And well, I'm now going into other sort of questions. Well, Girls in Quantum is like a sort of a community or an organization that wants to involve more women and students in the field. Do you think that it's important to involve more women in the field of quantum computing as you're involved in quantum?
Absolutely. And I mean, I come from technology, so I think that applies to technology and science in general, not just quantum computing, but absolutely also quantum computing, because just there's been a lot of research. I typically, I'm a person that looks into science for like evidence, and there's a lot of research supporting the fact that when within companies who have a culture of supporting diversity, increasing diversity, and they build diverse teams where everybody can be themselves, they generate more ideas, they're more productive, and they make more innovative solutions. So, and that absolutely applies to quantum as well. It's no exception. So yes, I do believe it's very important.
Awesome. Yeah, that's really good to know. And I also, well, in respect with that, I also wanted to know for people, so people may wonder, why would you collaborate with Girls in Quantum, with an organization like us?
Well, it's, I mean, we want to do our part to, first of all, increase diversity in the entire field, but also within our company. I mean, to be honest, we've been so like busy building our product that I wouldn't call that we're in a good place right now with diversity, but we want to change. We want to, so working with organizations like Girls in Quantum provides two things. First of all, it gives us visibility for potential women recruits, talented women and girls. And second of all, supporting organizations like Girls in Quantum helps these organizations kind of attract more girls into quantum computing, which is of course a longer term thing, but important nevertheless.
Yeah, of course. And there's definitely like, there are going to be like many women looking at this video. So it's definitely like, there's an opportunity right there if they want to be like involved in quantum computing and in this field. So definitely, thank you. And well, I was wondering, now that we have like all of these students here, we have like sort of age range from 16 years old, even 12 in ahead, even undergraduate students and graduate students. So what would be your advice for them if they want to be involved in quantum?
Well, there's basically, I think, two approaches to this. If you really want to kind of be involved in the technology, do the science, there's no shortcuts. You need to learn your mathematics, you need to learn your physics, and just having a strong, solid foundation on those really helps. The business probably is changing. So I do feel that in a few years, there will be more like abstraction, so that people who are actually good programmers might be able to also do something with quantum computers. But as we speak today, it requires strong math skills. But then, of course, not everybody working with quantum needs to know this. I'm an example of that. So I mean, you can also just look into everything that's written in the media about quantum. There are specific medias like Quantum Insider that really publish these high-level things on what's going on within the industry, how quantum computing can be applied to different things. So there's always need for the dark side, the business side people as well, particularly in companies.
Definitely, and I totally agree. I think that's really important also to like get immersed in this sort of all the resources that are out there and start learning about it. Like with physics, maths, I believe that, as you said before, it's not always easy to understand some concepts. But well, definitely, you can also like revise some materials that Girls in Quantum have, and all of that in order to keep learning. And well, just now for concluding the interview, I want to, well, you partly answered the question before, but what are your expectations for the next 5 years for Quantum?
Well, I think one big thing is I don't believe that we'll achieve like fully error corrected or error tolerant quantum computers. Will still be in the NISQ era, but I do believe that there will be real life industry use cases where quantum advantage is proven. I hope that QuantScience and our physics simulations is one of those. We're well on our way there. And the other thing is kind of that the ecosystem for creating software for quantum computers is improving. So all these higher level abstraction tools will be there. So basically meaning that people with great programming skills can do something. So I think those are two big things. And of course, like more qubits, less noise, all that. The hardware is improving in huge speed all the time.
I'm really happy that we could have like this interview, Juha. I think that, well, this is the end, and I really appreciate that you could talk more about your experience, how it's working in QuantScience, a company that it's working in quantum simulations, so people can get to know that, students can have like your advice and also learn from someone who is already involved in the field of quantum. So I really appreciate it, and thank you so much for having the interview with us.
Thank you so much, Elisa, for having me in this interview. And I have to say, I'm super impressed with the work you've been doing at Girls Quantum. It's a great initiative. So all the best for the organization, and I hope we can collaborate some more in the future.
Of course, looking forward to it. Thank you so much.
Thank you.